Hey, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench, I have, it's not a repair, it's more like a inquiry. No, it's not an inquiry, it's an oddity. I have an AWA distortion and noise meter. It's an F242A, Amalgamated Wireless Australasia Limited. Purchased this on eBay for a decent price. I thought it was okay for what it is. I thought I could use this for doing amplifier evaluations, before and afters maybe, and it's capable of measuring noise levels and distortion. That's why I got it. So, but I'm having some troubles here deciphering this manual that came with it. This was manual I downloaded. I was going through reading it and trying to figure out how to operate this thing. I have, for the most part, I have the noise level reading, or the noise meter portion of it figured out. I just don't know the distortion meter portion of it. Either it's faulty, or I don't know what I'm doing, or maybe it's working right, and I just don't know. So let's go through this and see what we have here. So here we are on the left-hand side of the unit. We have our great big meter. It's about 4 inches across, 2 inches high. So it's an oversized meter. It's a really nice precision device here. Top scale reads dBm from -30 up to +2. Bottom scale reads RMS volts and percentages, and that's on a 3 and 10 scale. So depending on what range I select, you read off the top or the bottom, depending if it's 10 full scale or 3 full scale. We have our input here, and if I push balanced, there's provision for a balanced input on these two bottom terminals. If I press unbalanced, take the switch out, it grounds the bottom, and my middle lug here is the input signal. I'm really not sure what this black one is all about. It says 30 volts AC max, 200 volts DC, so there must be maybe there's a capacitor blocking in there. And 200 volts DC balanced floating max. Okay, so that's a maximum voltage. But here's our input selecting. We can go between balanced and unbalanced, and we can terminate with 600 ohms, or we can go bridging, which I believe is 50 or 100K input impedance. I'm not sure. I still have to read up on this. So for normal use, you just leave them both out, and this would be your ground, and feed your signal into your middle pin here. On the other side under the meter here, we have filters, and we have 3 filters to choose from. One's a weighting filter. One is a low cut filter, so anything below 400 hertz gets cut. So if you want to filter out power line hum, you would press that one in. And then the next one is a high cut filter, 20 kilohertz and up. So that would cut off highs if you press that one in. So normal operation, I guess you'd leave all these filters out, and then it would read flat. It says it reads flat from 20 to 20 kilohertz. So on the right hand side of the unit, I got a power switch, and it's kind of, I'm going to turn this over because it's not intuitive to what I'm used to. Usually when you turn a switch on, you flip it up, and in this case it turns it off, which isn't correct for me and the way I've been programmed to run switches. It's got an illuminated lamp here, which is good. In the center of the unit, it's got set reference, fine and coarse. Okay, I'll get to that more later. And it has one of 4 functions. So we can measure noise levels in dBm, and this is from 10 hertz to 100 kilohertz. Or we can measure, this is absolute, or this is relative. And we can press relative, and then we can use it as a comparison tool to measure relative to another signal. And what we would do is, if you had a signal that you wanted to measure relative to, you can press relative and set the reference level with these coarse and fine adjustments, okay? And then you would use it to compare before and after. If you just want to measure absolute, these relatives shouldn't have any effect. Should be out of the circuit. So actually you're measuring according to the range you select, right? That's for noise level measurements. For distortion, this is the part I don't understand. I was trying to read this in the manual and it didn't make sense to me. So 20 to 20 hertz fundamental, and you would hit calibrate and then set the reference with this. But I don't understand what you're setting it against. And then when you want to read the distortion, you would press that and you would read it off your meter according to your scale. This scale goes from plus 30 dB, plus 30 volts, all the way down to, well, 0 dB, which is 100%. It says 100% here, and then 1 volt. And then it goes down to minus 80 dB, and it reads up to 100 millivolts full scale. Okay. And that's 0.01%. So that would be your scale you'd read your percentage on, I'm assuming. The lower the distortion, the more sensitive you got to turn this thing. And then it has an output. Output, I'm not really sure. If you just want to monitor the signal through an amplifier, I guess you could. Frequency out of range. So if you feed this with a frequency outside of the 20 to 20, or maybe the 10 to 100, I think this light comes on and gives you a warning that your reading's invalid. So let's have a little, let's goof around with this thing a little. Well, actually, you know what? Let's have a look inside. It's pretty impressive. All right, so 4 screws on the sides. Top comes off. Another 4 screws. You can remove the bottom cover. So here's the top cover. It's aluminum. And here's a look inside this beast. It's quite impressive. It's got a lot of circuitry, a lot going on here. Let me move this closer. So in this top hand corner we got a fairly small power transformer. It doesn't use much power. I think about maybe 15 volt amps or so. And this is all shielded. It's got mains input. You can select between different mains voltages. A little power supply section here. Filter caps. It's got a plus minus 12 volt regulator on this little heat sink here. And this whole section here is power supply. Lots of stuff going on here. This circuit here is for the meter driver and the output circuit. This cable here that goes across the back goes to the output out front. So they must have some kind of amplifier here for the output. And this is for the meter driver. This is a meter amp here in this circuit here. And lots of different blocks. Frequency range control and some logic circuits. What's this one here? This is in-phase generator. Whatever the hell that means. Over this way it looks like you have a impedance matching transformer. That's what it looks like to me anyway. And it comes from the input circuit. Underneath here is an input circuit which has the 2 switches for the balanced, unbalanced, and the different impedance. And there's a relay down there. So it's really well built, high quality components. I gotta stress that. Incredibly high quality. The switches down underneath on these circuit boards here are all gold plated. So they have minimal contact resistance and maximum reliability. Got our big meter here. There's the 2 wires for their meter. The meter's right here. This little circuit here, I don't know what it is, but it's some kind of tuned circuit. It's got some inductors and some precision capacitors on it. Very few electrolytics. There's a couple down here. There's a couple back here. And that's just about it. The rest of them are tantalums. You see these big silver cans? These are all tantalums. And they're probably military spec. And then the other capacitors it's full of is these styrenes. Here's a styrene capacitor here. Here's another one. This is a 1% capacitor. A lot of high precision tolerance parts here. Here's a look at the back side of the front panel. This is our range switch. It goes back down to his circuit here. And this is the fine and coarse relative setting. Looks like it has some active components here as well. And all these tantalum capacitors. Back side of the big meter. And you can see the switches for the function and the filters. It's very well built. There's no messing around with this thing. It was built to perform. So I was playing around with it a bit here just to try and test it out, see if I could figure out how it works. And I did figure out the noise level readings, and I did figure that one out. So let's try this. Let's turn it on. All kinds of relays clicking and stuff inside. Turn the range switch up. Okay, let's connect the source. This is my signal function signal generator. It's got I'm going to connect that up, and it is turned off right now. But if I turn up the range switch, or turn it down, let's say, we should be able to read the background noise from this cable coming from the function generator. So if I keep going here, and I get down to the sensitive bits, and I go to -80, and it shows here -9. So that would be 89 minus 89 dBms. Is that correct? I'm guessing. And if I touch this, you can see how it goes up a little bit. So I'm picking up noise from my body, and it's getting induced into the input. Okay. If I go 600, it doesn't make a difference. Balanced, unbalanced. Okay, I'm not going to play with that. So let me turn on my signal generator. I got it set to a 0 output. Let me turn it on. And you can see a little bump there. Some noise that came through. Toggling it on and off. Okay, let me turn this to 1 millivolt. And let's see here. Turn this range down. Let's turn this on. Yeah, 1 millivolt, and that's what it does. Comes out at 64, minus 64 dBm. And this is pretty accurate. If I switch it to -50, this goes to 14, from 4 to 14. So I know this is working, and it's accurate. So we can measure noise levels with this easily enough, just with this. Now if I want to measure something relative, I would press that in, and I would set these two knobs. I'm just getting used to learning how to use this thing. Okay, let's say for example, I'd set it to 0. And then I can disconnect this, input another signal, and it would show either greater or less. It picks up my body capacitance here. Okay. That's kind of useful, I guess, if you wanted to test between different amplifiers, see if one's better than the other, or if you make circuit modifications and you want to see if what you did to the circuit made it better or worse for noise. I guess that would be good. But you could also do it on the dBm scale too. Now, the part that confuses me is the distortion. According to this, this is the part I really don't understand. I'm going to feed in a signal. We got it set up for, let's turn up my signal generator, because right now it's at 1 millivolt. Let's turn it up to 100 millivolts. Okay, 100, maybe 200 millivolts. 3, 4, 5, 500 millivolts. Now this is what I don't understand. It starts making these noises. You hear all those relays clicking. It's like it doesn't know what it's doing. So I'm feeding a 500 millivolt signal in, and it's in cal right now, calibrate, which means I have to set the reference level with these fine and coarse knobs. Really not understanding how this works. Do I set it to 0? This switch has no effect. Okay, let's go to read. And now it's still doing its freak out thing. So we're on the 0 scale, the 1 volt full scale. So what is it reading right now? Is it reading the signal of 500 millivolts? I'm not sure. Let's try going up to the 3 volt scale. And it's still kind of the same thing. It's reading about half a volt, 0.6 volts here. But I don't understand what this is all about. I've been trying to read the manual. The manual is pretty involved. I have to sit down and try and decipher it. But my question to you guys is this thing defective, or is it? Am I not using it right, or what's the story here with this thing? Yeah, I'm just trying to figure this out. I'm just trying to understand how this works. If I feed in a pure sine wave of, let's say, 1,000 hertz, we should be able to read a low distortion on it. But I don't know what's going on with this clicking inside the relays and getting really high readings. So let's try this again. Let's say set it to 0. I don't know why I'm setting it to 0, but I am. And let's read this. It reads about half a volt. Let me try a different frequency. That's 1,000 hertz right now. So let's turn it to, let's turn it down to 400 hertz. 700, 6, 5, 400. So what is going on with this thing? It just dropped off the scale here. So we're on 10 millivolt scale and we're reading halfway up. So about 5.5 millivolts. Or minus 43 dB. I don't know. That's off the scale. So I was hoping maybe one of you guys can tell me what's going on with this thing. Is it broken, or is it operator error? So I'm going to post this up. Maybe you guys can help me out on it. So I'm going to continue reading the manual here and playing around with it, see if I can figure this out. It would be nice to use this for distortion measurements and noise floor measurements as well. That's just really what I got it for. So, but like I said, I don't know if it's running. The way these relays are clicking inside on and off, it really, turn it back up. It really has me wondering what it's trying to do. Turning it back up to 700, 800 hertz. 800 hertz. Starts freaking out. And I am feeding it a nice sine wave. Alright, well thanks for watching, and I'll see you in the next one.